In this video, I'm going to show you how to measure RF output power of this Yaesu FM transceiver FT-2800M. We're going to be using this RF power sensor, the attenuator, and then we're going to compare the measurement to this Agilent RF power sensor. So let's get started. Here we have the operating manual of this FT-2800M FM transceiver. This is a 2-meter transceiver. Frequency range is between 144 and 148 megahertz. And there are 4 output power levels: 5 watts, 10 watts, 25 watts, and 65 watts. Next, the RF power sensor operating frequency is between 1 megahertz and 1000 megahertz, which means the 144 to 148 will fit just fine in between those two numbers. And input signal range is between -40 dBm and +15 dBm, which is equivalent to 0.1 microwatts to 32 milliwatts. That means that this sensor cannot be directly connected to the output power or output connector of the radio. Instead, it needs to be connected through the attenuator. This attenuator is designed for up to 50 watts and 40 dB of attenuation. On this end, you connect the sensor, and on this end, you connect the radio. So first thing we're going to do, we're going to connect the sensor to the attenuator. And it looks like this. It becomes a single unit. Next, locate on your desktop Smart RF Power Sensor icon and start the app. First, we're going to enter the frequency. Since the radio operates between 144 and 148, we're just going to simply enter the 146 megahertz, which is a value in between. And then we're going to enter -40 dB, which is the attenuation of our attenuator. Apply. And we want to measure RF power in watts, so click watts. Next, we have a coaxial cable which is connected to the output of the radio, which needs to be connected to the attenuator. To do that, we need an end-to-end adapter. And connector goes here. Make sure everything is tightly connected together. And we can now switch the power on the radio. Again, this radio has 4 output power levels: 65 watts, 25 watts, 10 watts, and 5 watts. We are first going to test the radio at full power. Let the number set 58.5 watts of output power. Next, mid-level, 25.9 watts. Low 2, 10.7 watts. And the fourth output power level, 5.2 watts. We are now going to compare how well the Smart RF power sensor compares to this state-of-the-art Agilent RF power meter. Before we get started, we first need to set the frequency of this device to 146 megahertz. We need to set the attenuation 40 dBs, and then we need to calibrate this power meter. After the calibration, we are now going to connect this sensor to the output of the attenuator, and then we're going to measure RF output power levels again. First, highest output power level. Let the numbers set 58.0. Mid level 25.8. Low 2 10.5. And low 1 5.22 watts. Here are the numbers we have just obtained. On the top we have the RA1M1000A made by WTMA. On the bottom is the E9301A sensor made by Agilent. For low 1 power level, two numbers are identical. Low 2 10.7 and 10.5, mid-range 25.9, 25.8, and the high range 58.5 and 58.0. Clearly, these numbers are almost identical. This measurement over here is not due to the sensor itself, but it's actually due to the radio, it looks like. Because if you remember, the power started off as 65 watts and then gradually dropped over the few seconds down to 58.5 or 58.0. So this is probably due to the flaw in the design of the radio. In summary, we've just obtained two sets of measurements. One with this high-end RF power meter, which consists of the base unit and the sensor, and the other with this compact USB-powered sensor. Clearly, the data that we have obtained is comparable between these two units. However, this unit here is small, compact, and is perfectly capable of performing these simple measurements. In the end, before we end this video, one more time, what we've just observed is that even this RF power sensor can only measure power levels up to 32 milliwatts. This sensor can easily be connected to an attenuator, in which case these become a single unit, and the power can be referenced to this point. At this point, you can then have RF input power up to 50 watts, and the sensor simply measures the power at this point. Lastly, we're going to look at different ways of displaying the RF power level on the screen. If we look at the power in watts, at high power level, this radio puts out about 58.0 watts. We can also display the power in dBms. This is equivalent to about 47.6 dBms. Or we can look at RMS voltage on the input of the attenuator. The voltage level on the input of the attenuator is about 54 volts RMS. Thank you very much for watching. Like and subscribe for more videos like this.